Most feline species, from domestic cats to cheetahs, produce a special vocalization, purring. The purring cat is the epitome of contentment. But there's much more to purring than meets the ear. Most scientists say that purring begins in the brain. A rhythmic, repetitive neural oscillator sends messages to the laryngeal muscles, causing them to twitch at the rate of 25 to 150 vibrations per second. This causes a sudden separation of the vocal cords, during both inhalation and exhalation, the unique feline vibrato. However, scientists still cannot explain all the reasons why cats make these rumbling sounds. Cats purr when they're nervous, when they want something, and when they're happy. They also purr when in pain or in labor, when ill or injured, or even when near death. One of the assumptions is that this vocalization contributes to the healing of bone and tendon injuries. This is due to the fact that the sound waves in the range of frequencies between 25 and 140 Hz can improve bone density. However, this theory does not explain why cats purr in a variety of situations. Does looking at an image of a person yawning make you yawn? About half of adults yawn after someone else yawns due to a universal phenomenon called contagious yawning. Previous research of brain scans showed that the area responsible for attributing mental states and feelings to oneself and others becomes active when people watch others yawn. On the contrary, many people with autism and schizophrenia do not show such brain activity and do not yawn after others as frequently. From this, scientists suggested that the infectiousness of yawning reflects the ability to empathize and create normal emotional connections with other people. In spite of that, new studies did not find a strong connection between contagious yawning and empathy, intelligence, or time of day. The only independent factor that significantly influenced contagious yawning was age. As it increased, participants were less likely to yawn after others. However, age, being the major factor, was only responsible for less than 10% of variation in the contagious yawning response, so this phenomena still remains an unexplained mystery to scientists and a better understanding of the biology involved is required. We know the initial cause of a lightning strike, it's a separation of charge within a cloud. A positive charge accumulates at the top of the cloud, and a negative charge at the bottom. This attracts a positive charge on the ground underneath the cloud while the rest of the Earth's surface remains slightly negative, and, when the electric field between the ground and the cloud becomes strong enough for the air to ionize and become conductive, a quick discharge lightens the skies, usually followed by the thunder. There are two types of lightning. Negative lightning happens in 90 to 95% of all cases when a charged bolt strikes between the ground and the bottom of the cloud. It is very dangerous and typically is about 300 million volts and 30,000 amperes of power. The most hazardous, however, is the positive lightning that happens when the charge at the top of the cloud is not shielded by the bottom due to the cloud's shape or different winds that can tilt the cloud. Because this strike has to travel over much larger distance, it can be many times stronger, reaching 1 billion volt and 300,000 amperes. The gigantic voltage and longer-lasting bolt is the reason positive lightning cause so much damage and so many deaths. It is usually the cause of forest and house fires, damage to planes and power grids. However, how a cloud becomes charged in the first place is still a scientific mystery and an area of active research. One theory suggests that as water vapor rises in the cloud, it acquires a charge via friction with dirt, dust, and other materials. According to another theory, the charge separation is due to the general flow of droplets of water inside the cloud as it turns into ice and snow pellets while freezing. For some reason, the positive and negative charges do not try to reach each other and stay separated. One possible explanation is that negative particles are larger and heavier, so they stay at the bottom of the cloud because of gravity. We observe this phenomenon so often that it no longer causes much curiosity. However, science has still not understood such suicidal tendencies of insects. Some entomologists believe moths zoom toward unnatural light sources because the lights throw off their internal navigation systems. Moths evolved to navigate in the distant dim light coming from the moon and the stars. This is called transverse orientation, the movement of animals at a certain angle to the direction of the stimulus. But around man-made lights in close proximity, such as a campfire or your porch light, the angle to the light source changes as a moth flies by and it confuses the insect. However, opponents of this theory argue that in the last 400,000 years, during which there were man-made bonfires, moths would have died out long ago. In addition, according to researchers, not all moths affected by the lights migrate and therefore rely on the transverse orientation. Another theory was based on the discovery that the infrared light spectrum emitted by a candle flame happens to contain a few of the exact same frequencies of light given off by female moths' pheromones. So male moths could be attracted to candles under the false belief that they are females sending out sex signals. However, ultraviolet light was found to be far more attractive to insects of various kinds, including moths, than infrared, and UV doesn't contain wavelengths present in the glowing pheromones. So far, no hypothesis holds water very well. Why are moths attracted to lights and flames? For now, the question remains one of life's little mysteries.